again. So I'm going to start by welcoming you all. Good morning, good afternoon, good evening. Probably you are surprised that we are having such welcoming, and why I'm saying good morning, it's because, well, at my place it's just perfectly noon, but probably we are having people with different, we have participants from Australia, Middle East, Mexico, Brazil, Lativa, so we try to be as inclusive as possible. So on behalf of CPEX Global, I'm Anastasia, and I would like to welcome you all to ISO 12647, heading for printing process, conformance, and standardization. You might all know that in Germany, there are 250 printers that are ISO certified. So this is important to be ISO 12647 if you are associated with the printing business, either flexographic, offset, or rotogravure. So in this session, we have an amazing trainer, Dr. Abhay Sharma. Hello, welcome.
Good morning.
Who has an amazing professional experience in color management and that particular ISO implementation. In this session, he will provide you insightful learning for various parts of that, requirements, implementation criteria, etc. Give back voice to Dr. Abhay Sharma, that is going to do the great presentation for us today. I will remind you about the break in 1 hour or so, so everyone can feel comfortable and have their needs met. Thank you very much. The mic is yours, Doctor.
Thank you. Thank you. Good morning, good afternoon, good evening. Thank you, Anastasia. Great introduction. So welcome. We have, this is our title for today is graphic technology, and we're heading for process conformance and standardization. We're going to be talking about color, about numbers, measuring. And here you see a number, ISO 12647 is one of the main standards that we'll be talking about. 7 established process control parameters and their aim values and tolerances. So that's what we are going to, all of these red underlined bits are in the following slides. Process control parameters and aim values and tolerances. The concept for Flexo is in this -6. And the groundwork was laid in 12647-1, which we've just looked at. The current edition differs from earlier editions by not defining specific printing condition aims, but talking about reference printing conditions. So this is kind of what we talk about when we're talking about a standard. We're targeting GRACOL, FOGRA, a particular data set. And for Flexo, we have a very different way of printing, which all of you know, or many of you are doing that with analogs, rollers, and different substrate types. So these are some of the things that we need to just pick up in the next hour that relate to printing to a standard for flexography. The purpose of a proof is to stimulate, to simulate the visual characteristics of the printing product, the final product. So we don't want to just make a proof that doesn't give us a preview of the printing process that is going to actually happen. And that is a contract proof. Sandis talked about doing it with GMG. Excellent, excellent solution that in many tests I've done are the most accurate in the world. And they hang their hat on understanding the printing process and accuracy, and they always nail it. Of interest to us is this similar appearance idea, and that is that if we have a package that is printed across many different media, or a graphic from a big brand, Procter & Gamble, we want it to look the same on the different printing processes. So the cardboard, the point of purchase display, the package itself, maybe even the box that it comes in, the Coke cans come in a carton. So we would like a similar appearance on all of these different printing processes. And then spot color, Flexo, nearly every job will have spot color, and specifying that spot color in terms of spectral data in an XML format. So here are some of the new ideas or the things that are relevant, specific to Flexo that we'd like to look at. A quick summary of how flexography works. So if some of you are offset or in the digital prepress work, there's a analox roll that picks up the ink. So this is the ink metering system, and on the top right here, it has these pits. And so these pick up the ink, and that's important here. So the ink is picked up in this analox roller, and these are predefined. So when you mount this on the press, this is smaller or bigger cells. So these cells are smaller or bigger. BCM, billion cubic microns, is the volume, and you have different ones which are loaded. So the job, you can't tweak more or less ink. You've loaded this cylinder, and it has a certain amount of capacity that it picks up and then is scooped off. The top is scooped off, and it passes that onto the plate, which is then passed on to the substrate. So I'll say it again. Those of you that are offset printing have ink zones that can be turned up or turned down. Here in flexography, we have no way to alter the printed result. So all we can do is change the viscosity of the ink in the ink chamber or change the analox roll. But during the press, the printing, we can't change that. So we have the ink that we make to a certain viscosity. We allow it to fall and be picked up in these cells, and then it's held in those cells and passed on to the flexographic plate. It's just a contact and transfer. So it's just a kiss cut and a transfer. And then it goes on to the substrate. So the difference is that there's no ink metering per se. The ink metering is the analox roll. We also need to match the screen ruling of the plate and this analox, these cells. So these cells can have a different screen ruling, and they need to match the plate. And it's two very different parameters. We have, where was my sample? There's solids, and then there's halftone screens. So there's an image, and then there are solids on most packages. And at the moment, for part 6, we are only talking about 4-color flexographic printing of packaging, but we would really like to expand that to 7-color. So as I said earlier, there's halftone images, and then there are solids. 7 talks about 4-color flexographic printing. It's used for packaging and publication materials, labels in the main. So 12647-6 is directly applicable to all of these categories, and spot colors forms a large part of that. And the communication of spot color information also forms a large part of that. And because of this communication about spot colors, that's why it's been built into the standard, because we weren't communicating that information effectively. And so really unique in -6 is how to specify spot color information. And when we were doing some introductions at the start, many of the people on the call were in spot colors for flexography. Most of the standards, 12647 from 1 to 8, also have many substandards. So at the back of them, they are supported by many other substandards. So we don't like to duplicate work, but these are references, if you like, to the original 12647, including, in fact, pointing to another 12647 standard where appropriate. So it does get into a network of standards, and you can get lost in this spaghetti maze, but let's just focus on 12647. That's really where we talk about, and that's the essential part at the top here. We will need to look at some of the definitions, fringe width, printing form, and that E is intentional. It's the way that the standard talks about the cylinder or sleeve, the provider, the receiver, the replacement color. If a spot color is not used, then alternate separations, the screen ruling, and then spot color, whether it's a single spot color ink created from a CMYK build, and how it's specified. Even though there is spot colors in offset printing and gravure, it's in flexography and packaging where we really pay special attention. Input for flexography. So are we all doing CTP? So quick question, are we all, if you're a flexo printer involved in the flexo process, are we using a CDI direct to plate? So we're using a CDI. Gulf Carton says yes, great, yes. So that really makes everything controllable. Is it ESCO CDI? DuPont, Gulf Carton, which system do you have? CDI, perfect, that's the one I have. Good automated workflow. Yeah, good. So ESCO, and they're really developing new plate technologies. CDI, good. So anybody else here? Lang, do you have a CDI? Llewellyn? Okay. So for Flexo, we need to look at distortion, proof requirements, and digital data files. So this distortion idea, maybe Gulf Carton, you guys are doing CDI, you explain what is this distortion. And so here we have a running track, and even though they're all running the same distance, they have this staggered start. So Gulf Carton, help me explain what this distortion is. So it's done within the system, but yeah, if you wanted to unmute anybody that's a flexo printer, help me explain this distortion aspect. So because the plate has a finite thickness, it's not flat, that the outer bit actually has a bigger running circle than the inner part. So is my camera on? Why can't I see my camera? Maybe because I'm not host.
We can see your camera.
We can? Okay. Okay, good. So because the inner circle has a smaller distance to run than the outer circle, we have to distort that so that when it's printed and it's laid flat, then they all have the same distance. So we don't have, the graphics don't get distorted. So we have about a 95, 97% distortion factor depending on how thick the plate is. So that's something that is unique to flexography due to the raised surface and the thickness of the plate. So a raised surface is what we use in flexography, and so we have a distortion correction, and then of course it's mentioned in 12647-6. Nothing new with the color separations. We've talked about this. What we may talk about is the angles and also the dot structure. We just, Gulf Carton are using CDI, I'm using CDI, so we wouldn't necessarily talk about film, but if anybody really is, then they, oh, okay, thank you. So we have an explanation texted in. The distortion is the compensation of the image according to the circumferential size of the cylinder. Thank you, that was chatted in. we must have a control bar. And in Flexo, we have this highlight dot, which is a physical dot. And I'll show you some pictures in a moment. These physical dots get very small for the highlights. And so we often will do a bump plate to increase those smallest dots. So because they're a physical dot, it's a physical tiny little pyramid. When they're bigger, they're higher density. If you want only a 2%, 5%, 3%, they get smaller and smaller to accept the ink and pass it on to the substrate. So unique in flexography is this pyramid. And for a high tone, for a lot of ink, it's big, and then it gets smaller and smaller. And for highlight dots, it gets very small. And physically, as it gets hit, if we go back here, Anastasia, you can do the waiting room.
Yes, of course.
Where was my flexo diagram here? So we have these tiny little pyramids on the printing form, and at high speed, they hit the impression cylinder. So after 50, 100, 1,000, 5,000 impressions, this tiny little rubber peak can get knocked off. And so highlight dots are susceptible to a missing highlight dot. And so we need to think about a bump plate, or we think about those very small dots in flexography. And that's what we are, and that's why the test form should have more distinction at this lower level to receive those, to contend with missing highlight dots in flexography. And here are the measurements that we may consider and make, and offset Flexo standards would talk about that. So the highlight dot is something that's unique, and that must be built in to this test form. And so here tone values below or equal to 10%, and then above 10%. So below 10%, we really want to be a lot finer in how we deal with our plate. Nothing special about hue angles, but here's what we should set. And the software, we had Golf Carton as CDI, so that has them preset. You can choose from the preset. If for a particular job you want to change it, then you can, but really you print according to 12647. That's a preset in most of the software, and it will set you the angles of the screen. And we looked at the screen with the microscope in the first half of the session. That's what we're talking about. But at the end of the day, agreement shall be reached between the provider and the receiver at the bottom of this slide. So for halftone images in the package, we may consider this. For solids, it's not necessarily that significant. The CDI users and all of the Kodak systems are all coming up with different dots, digital dots, making them a lot better, a lot finer. All of you who are doing this sort of work will have a Betaflex or equivalent, captures a digital image like this, analyzes the circularity of the dot, and is used in this process control. And so if we're printing to a standard, we need to study the plate right from this level here, and all of the values that we should be getting are provided. But if we're not doing this, we don't have this equipment, or the equipment's there and our operators aren't using it, then that's really what the message is for today. Does anybody have a Betaflex or equivalent system that they must be observing their plate on?